Going on, guys? In this video we are going to see how to do triple integrals using cylindrical coordinates. Here we have the function in terms of rectangular coordinates. Now we have to convert this one into cylindrical coordinates. When we convert rectangular coordinates to cylindrical coordinate, this x will turn into r cos theta, y will turn into r sin theta, and z will turn into, z will remain the same, that's going to be z, and this dv will turn into r dc dr d theta. And also when we have x square plus y square, we can replace this one with r square, same as polar coordinate. Okay, now here we have r square. Now this function is going to be just r square, so this is not a problem. Now we have to find out the limits of integration. Now to find the limits of integration, we know that base is this circle. Now to find the base equation, we have to set this z is equal to 0, because in base z is equal to 0, because this is going from 0 to this one, right? So base is 0, let's equate this one to 0. 0 is equal to 4 minus square root of x square plus y square, and if we rearrange this equation, this is going to become x square plus y square is equal to 4, and if we square both sides, this is going to turn into x square plus y square is equal to 16. From this one we can see this is a circle with radius 4. So this circle is going to be 4, and here we're going to have negative 4, negative 4. Now we have the base, and also we know that this is going from 0 and this is going to end at the cone. So we know the equation of this cone is given by 4 minus square root of x square plus y square, but when we write in terms of cylindrical coordinate, we have to replace this x and y in terms of r, and if you plug these values, and we know that x plus y square is equal to r square, or you can try this way, r cos theta, r sin theta, you will get the same answer, r square, because sin square plus cos square theta is going to be equal to 1, right? Because we know that sin square theta plus cos square theta is equal to 1 in trig identity. So that's what's going to happen here. So instead of this, we can replace this one with 4 minus r. Okay, 4 minus r, because 4 minus square root of r square, that's going to turn into 4 minus r. So this is our z limits of integration, and for x limits of integration, we are going to have this one from origin to the radius, and radius will never be negative, so we shouldn't take negative 4 to 4, we should take from the origin, that's going to be 0 to 4. Okay, that's going to be the radius. Now we know the x limits of integration, that's going to be 0 to 4, and z limits of integration, that's starting from base, that is 0, and going until end of this cone, that's going to be, equation of the cone is given by this, and in terms of cylindrical coordinates, that's going to be 4 minus r. Okay, and also we need theta, because we are going to integrate with respect to dz first, then dr, after that d theta. So we have to know the limits of integration for theta. Theta, if you look at this one, we start from 0 and it's going to go until 2 pi. Okay, so this is 0 to 2 pi. Now we are ready to integrate. Now let's go ahead and write our integral. We are going to have triple integral, and instead of our function, we replace this one with r square. X square plus y square is equal to r square, and instead of dv, we replace this one with r dz dr d theta. So here we are going to have r dz dr d theta. Okay, now this r and this r square multiply, but before I do that, I have to write the limits of integration. So first, inside integral is going to be dz. So for z, it's going from 0 to 4 minus r. So this is going to be 0 to 4 minus r, and after that we have to integrate respect to r. So that's limits of integration of r. This is r. Okay, this is r. R is equal to 0 to 4, 0 to 4, and then theta, that's going to be going from 0 to 2 pi. Now let's simplify this one. R square times r, that's going to give us r cube, and here we are going to have dz dr d theta, and here we are going to have 0 to 4 minus r, and here we are going to have 0 to 4, and after that we are going to have 0 to 2 pi. Now if we integrate this one with respect to z, this is going to be a constant because we don't have any z. This one will be treated as a number, So this is going to be a constant, and when we integrate, this is going to turn into r cubed z, and the limits of integration is going to be z is equal to 0, z is equal to 4 minus r. It's always better to write z is equal to this one, this z is equal to this one, because if we don't write, sometimes we replace this one with r, right? So it's better to write like this. And then we are going to have 0 to 4 dr, and here we are going to have 0 to 25 d theta. Now we are going to plug this value instead of z, so this will become r cube times 4 minus r, and if we plug 0 for z, that's going to be 0, so this is going to be minus 0, so we don't have to write that one. Here we are going to have 0 to 4 and 0 to 25 dr d theta. Now let's get rid of this part because we need some space. Okay, now I am going to continue this one here. Now here we have r cube times 4 minus r. Now let's multiply this. R cube times 4 minus r, that's going to become 4r cube minus r power 4, and then 0 to 4 dr, and here we are going to have 0 to 25 d theta. Now if we integrate this one with respect to r, this is going to turn into r power 4, 4 times r power 4 divided by 4, so 4 cancels, we just get r power 4, and here we are going to have r power 5 divided by 5, and this is going from 0 to 4, and outside we have 0 to 25 d theta. Now also it's better to write r is equal to 4, r is equal to 0, but here we only have r. Now if we if we plug 4, this is going to become 4 power 4 minus 4 power 5 divided by 5, and if we plug 0, both of them are going to be 0, because this is 0 power 4 0, and minus 0 divided by 5, that's going to be 0, so we don't have to write that part. Let's leave it like this, 0 to 25 d theta. Now before we integrate this one, let's try to simplify this one. So this is 4 power 4, and if you plug this one in calculator, you will get 256, and 4 power 5, if you plug this one in calculator, you will get 1024 divided by 5 d theta. Now here we can take 5 as a common denominator, and if you do that and calculate this one, you will get 256 divided by 5. And now if we integrate with this one with respect to theta, this is going to be just multiplication of theta, okay, because we don't have any theta, so it's going to be just multiplication of theta, and this is going to go from 0 to 25, and if we plug this one, the final answer we are going to have is this one, 256 divided by 5. Instead of theta, we are going to plug 25 minus 0, okay, so 0 is not going to do anything, so 25, if we multiply this one by 25, finally we will end up with 512 divided by 5. So the final answer for this question is going to be 512 divided by 5, and that's going to be the triple integration of this function, and that's how we do it. I hope this helps. Thanks for watching.